This is SpaceTime Series 27, Episode 149, for broadcast on the 11th of December 2024. Coming up on SpaceTime, new observations suggest that Earth's oceans may have come from comets after all. Discovery of a new and rare main belt comet. And BepiColombo's successfully undertakes its 5th Mercury flyby. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists have discovered, much to their surprise, that water on the comet 67P Churyumov-Gerasimenko actually does have a similar molecular signature to the water found in Earth's oceans. The new findings contradict other research into the possible origins of Earth's water, and it reopens the case that Jupiter family comets like 67P could have helped deliver water to Earth. Knowing where our water came from is sort of important. After all, liquid water is essential for life as we know it. While some of Earth's water likely already existed in the protoplanetary disk of gas and dust from which the Earth was formed 4.6 billion years ago, some scientists believe that much of it would have vaporized because of Earth's proximity to the Sun's intense heat during its formation. So, exactly how the Earth became rich in liquid water has remained a key source of debate among scientists for years. We know that some of Earth's water originated through vapor vented from volcanoes. That vapor condensed and then rained down onto the oceans. But scientists have also found evidence that a substantial portion of our oceans came from ice and minerals on asteroids and possibly comets that crashed onto the Earth. A wave of comet and asteroid collisions with the solar system's inner planets during what's known as the Late Heavy Bombardment 4 billion years ago would have made this possible. While the case connecting asteroid water with Earth is strong, the role of comets has puzzled scientists. See, several measurements of Jupiter family comets, which contain primitive materials from the early solar system and are thought to have formed beyond the orbit of Saturn, show a strong link between their water and Earth's. This link is based on a key molecular signature which scientists can use to trace the origins of water across the solar system. The signature is the ratio of deuterium to regular hydrogen in the water, and it gives scientists clues about where the body containing the water likely formed. Now, deuterium is simply a stable isotope of hydrogen, which, unlike normal hydrogen atoms, sometimes called protium, and which are composed of a single electron orbiting a single proton nucleus, deuterium also contains a neutron in its nucleus. But it's not very common. Just one out of every 6,420 hydrogen atoms on average is a deuterium isotope. When compared to Earth's water, this hydrogen-deuterium ratio in comets and asteroids can reveal whether there's a connection. Because water with deuterium is more likely to form in cold environments, there's a higher concentration of the isotope on objects that form far from the Sun, such as comets, compared to objects that form closer to the Sun, like asteroids. And measurements within the last couple of decades of deuterium in the water vapor of several Jupiter family comets showed similar levels to Earth's water. The study's lead author, Kathleen Mandit from NASA's Goddard Space Flight Center in Greenbelt, Maryland, says it's starting to look like these comets may have played a major role in delivering water to Earth. Her research, reported in the journal Science Advances, revises the abundance of deuterium in the comet 67P. But back in 2014, the European Space Agency's Rosetta mission to Comet 67P challenged the idea that Jupiter family comets help fill Earth's water reservoir. Back then, scientists who analysed Rosetta's water measurements found the highest concentrations of deuterium of any comet, and about 3 times more deuterium than what there is in Earth's oceans. So Mandit and colleagues decided to use an advanced statistical computation technique in order to automate the laborious process of isolating deuterium-rich water in more than 1,600 Rosetta measurements. Rosetta made these measurements in the coma of gas and dust surrounding Comet 67P. And Mandit's team, which included Rosetta scientists, was the first to analyse all of the Rosetta mission's water measurements spanning the entire mission. You see, the researchers wanted to understand what physical processes caused variability in the hydrogen isotope ratios measured in comets. Lab studies and cometary observations had already shown that cometary dust could affect the readings of the hydrogen ratio that researchers detected in comet vapour. And that could change science's understanding of where cometary water comes from and how it compares with Earth's water. The authors found a clear connection between deuterium measurements in the coma of Comet 67P and the amount of dust around the Rosetta spacecraft, showing that the measurements taken near the spacecraft in some parts of the comet's coma may not have been representative of the true composition of the comet's body. See, as the comet moves in its orbit closer to the Sun, its surface warms up, and that causes gas to be released from the surface, including dust which is coated in bits of water ice. And it just so happens that water with deuterium tends to stick to dust grains far more easily than regular water. When the ice in these dust grains is then released into the coma, this effect could make the comet appear to have far more deuterium than what it actually does. Mandit and colleagues say that by the time the dust gets to the outer part of the coma, at least 110 kilometres from the cometary body, it's dried out. And with the deuterium-rich water gone, the spacecraft can accurately measure the amount of deuterium coming from the cometary body. This all has huge implications not only for understanding a comet's role in delivering Earth's water, but also for understanding cometary observations which are providing insights into the formation of the early solar system. Mandit says it means there's a great opportunity to revisit past observations and prepare for future ones that can better account for the effects of dust. This report from NASA TV.
One of the things that makes comets exciting is the fact that they're dynamic and changing and a lot of activity.
Rosetta is trying to understand the physical, chemical, and geophysical properties of Comet 67P.
We have many ways in which we're trying to understand it. What is this thing made of? How is it structured? How does it work? How does it absorb heat from the sun, and how do these gases come out?
What's really happening inside the comets?
The mystery of what comets are like inside has baffled humankind for decades. Comets have only proved us wrong time and time again. Part of science is sit on the ground and deduce what's happening far away. Started out thinking that comets were maybe a floating sandbank. There was a time that we thought of a comet as like an onion with layers. And then we went to a dirty snowball. It turns out that that's just completely wrong.
What is exactly the nucleus was not clear before, and we are now getting to understand what a nucleus is made of.
And we started to see the features that are on the surface. Everything was different from what we expected.
We see smooth, sandy-looking areas. We see cliffs that are a kilometer high. We see rough patches. We see rocks. We've never seen anything like this before.
We see that the surface of the comet is mostly organic dust. Below that is harder crust.
More questions are arising from what lies beneath that surface. The radar tomography is the first attempt ever to see inside the comet. We can see that this comet is very rich in ice. It's just hidden by the crust of dark material.
The composition of ice is still something that we don't completely understand.
What it is very extraterrestrial. So the properties of ice and the properties of rock may be really important for explaining how this comet works and maybe more comets in general.
And then eventually get at the big question of how comets form and how they might have contributed to the formation of other planets like the Earth.
And in that report from NASA TV, we heard from Essam Hegyi, a co-investigator on the CONSERT instrument on the Rosetta mission, Rosetta mission project scientist Claudia Alexander, Rosetta mission participating scientist Murphy Gapati, and the deputy principal investigator for the MRG instrument, Mark Hofstetter. This is SpaceTime. Still to come, discovery of a rare main belt comet, and the BepiColombo's spacecraft undertakes its 5th Mercury flyby. All that and more still to come on SpaceTime. A mysterious object discovered in the main asteroid belt between Mars and Jupiter back in 2021 has now finally been identified as a comet. Main belt comets are icy objects found in the main asteroid belt rather than in the cold outer solar system where most comet-like bodies usually originate from. Main belt comets have regular cometary-like features, including tails extending away from the Sun, and fuzzy clouds of gas and dust called comets, which originate from the comet's nucleus. They were first discovered back in 2006 and belong to a larger group of solar system objects known as active asteroids, which look like comets but have asteroid-like orbits in the warm inner solar system. This larger group includes objects whose coma and tails are made of ejected dust produced after an impact or through rapid rotation, rather than just the ejected dust due to the vaporization of ice. Both main belt comets and active asteroids in general are still relatively rare, but scientists are now discovering more and more of them as they begin to learn what to look for. The study's lead author, Henry Heissch from the Planetary Science Institute, observed an active asteroid catalogued as 456P PanSTARRS twice using the Magellan-Baade telescope and the Lowell Discovery telescope in October 2024 to establish its status as only the 14th confirmed main belt comet. A report in the journal Research Notes of the AAS suggested this object isn't just an asteroid that's experienced a one-off event that caused it to show activity one time, but it's an inherently active icy body, similar to other comets from the outer solar system. Heissch says that if 456P PanSTARRS activity were due to something other than ice vaporization, then its tail would be expected to appear only once randomly and not repeatedly appear whenever it was close to the Sun. An icy object, on the other hand, heats up every time it approaches the Sun, and the vaporized ice drags dust out along with it. On the other hand, when the same object then moves away from the Sun, it cools and this activity stops. Observations of repeated dust ejection activity during close approaches to the Sun are currently considered the best and most reliable way of identifying main belt comets. Heissch says there are very few confirmed main belt comets known, and he wants to build up the population so astronomers can get a clearer idea of what their broader properties are, such as their size, their activity duration, and their distribution within the asteroid belt. This would allow them to better use and trace ices across the solar system. This is SpaceTime. Still to come, BepiColombo undertakes its 5th Mercury flyby, and later in the science report, a new study claims that eating healthier during pregnancy has been linked to a lower chance of giving birth to a child with autism. All that and more still to come on SpaceTime. The BepiColombo's spacecraft has just completed its 5th flyby of the planet Mercury. The close encounter will help the probe burn off some of its speed as it prepares to enter orbit around the solar system's mysterious innermost planet in 2026. The spacecraft swooped down to within some 37,630 kilometers above the Mercurian surface. Now that's much further out than during its 4 previous Mercury flybys, when BepiColombo flew between 165 and 240 kilometres above the grey crater pox surface. However, this was the first time the probe was able to use its Mertz radiometer and thermal infrared spectrometer in order to study Mercury. The instrument measured how much the tiny planet radiates in infrared light, something that depends both on its temperature and the composition of its surface. In fact, it's the first time any spacecraft has measured what Mercury looks like in the mid-infrared range. The data that Mertz is collecting during its mission will reveal what types of minerals the planet's surface is made of, one of the key Mercury mysteries that BepiColombo is designed to tackle. BepiColombo's other science instruments will monitor the environment outside Mercury's magnetic field, including the influence of the constant stream of charged particles from the Sun called the solar wind on this radiated planet. Other instruments switched on during the flyby included the magnetometer, a gamma-ray and neutron spectrometer, an X-ray and particle spectrometer, a dust monitor, and an instrument that detects plasma waves, electrical fields, and radio waves. BepiColombo is a joint mission between the European Space Agency ESA and the Japan Aerospace Exploration Agency JAXA, and it's the most complex mission ever to orbit Mercury. It comprises 2 separate science orbiters, ESA's Mercury Planetary Orbiter and JAXA's Mercury Magnetospheric Orbiter. During the cruise phase of their mission to Mercury, the 2 orbiters are attached to a Mercury transfer module. But once they're about to achieve Mercury orbit insertion, they'll separate from the transfer module and move to their own independent orbits. Needless to say, we'll keep you informed. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. New research shows that eating a healthier diet during pregnancy is linked to a lower risk of giving birth to a child that will later be diagnosed with autism. The findings, reported in the Journal of the American Medical Association, are based on data from 2 large studies of parents and children involving nearly 85,000 pregnancies. The authors looked at food questionnaires, autism diagnoses, and autism-associated traits. They say that when calculating the overall healthiness of mum's diet, those who adhered to a healthy prenatal diet were 22% less likely to have a child who would later be diagnosed with autism. And children of mothers with a healthy prenatal diet were less likely to have social communication difficulties. A new study has found that mealworms are able to eat and digest microplastics. With microplastics being found in just about everything we consume, knowing there could be a solution out there is a big step forward. The findings, reported in the journal Biological Letters, suggest that these tiny creatures could play a small but very slow part in managing plastic pollution. The authors fed mealworms a mixture of bran and microplastics from melted face masks in the lab and found the mealworms consumed about half of the microplastics they were given without any negative consequences for survival and development. They say while this means that mealworms could play a role in tackling the plastic pollution crisis, it'd be quite slow. That's because it would take 100 mealworms roughly 4 to 5 months just to consume one face mask in microplastic form. A new study warns that the humble bumblebee's sense of smell could be impacted by heat waves. A report in the Journal of the Proceedings of the Royal Society Bee exposed bumblebees from 2 common European species to temperatures of up to 40 degrees Celsius, mimicking heat waves in order to see how it changed their behaviour. The authors found that after the heat, the bees showed reduced antenna responses to floral scents, suggesting that they may have lost their sense of smell. Scientists say this affected female worker bees far more than male mating bees, and the reduced sense of smell could make it harder for bees to find food. Samsung are testing the waters with proposed new artificial intelligence upgrades for their Galaxy smartphones. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
The underlying operating system of Samsung devices, it is Android, but their skin on top is called the One UI, and this is now up to version 7. So Samsung previewed the One UI 7 beta. Obviously, they talk about powerful AI features. These updates include advanced writing assist tools, so this is integrated into the OS. Text can be selected without needing to switch between application. So it's within the same interface, which is what you'd expect and something that you actually see on Apple devices. Normally, a lot of people are using AI tools, so they have to go from ChatGPT back to Word. And this is even though Word, for example, now has Copilot. I mean, there's a lot of integration. You've got upgraded call features where the call transcript now supports 29 languages, and this is where when call recording is enabled, recorded calls will automatically be transcribed for reference later on. This is only going to be for Samsung Galaxy S24 users to start with. Initially, it's going to be Germany, India, Korea, Poland, and the UK.
Do we know how often people upgrade their phones?
Look, it has stretched out as the cost of living has gone up and devices have become more expensive. I mean, people used to easily update their phone year on year. Now, of course, not everybody did that. And people have been holding onto their devices for 3, 4, 5 years. And that's why Samsung and Google and others are promising 7 years of updates for their devices. Now, clearly, a device that was sold in 2024 is not going to be anywhere near as exciting as a device sold in 2030. But if the updates are still made available, then the security updates is what is really of concern to most people because they don't want to get hacked. And we have seen a bounce back in the number of phone sales over the past year compared to the last 2 or 3 years where phone sales dropped off after a bit of a boost during the pandemic. So, people are holding on to their devices more than ever, but there's always the temptation to upgrade when you see these cool new AI features that are supposed to make your life easier.
That's Alex Zaharov-Reutt from TechAdvice.life. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.